Hey there, Joe Braun here, the DCS Mech Warriors. In this video, we're going to tune a PID controller using the information we gained in the previous video, our max velocity test. So let me switch over to my screen and we will get started here. So we're going to go down to Team Code and Java and then open up our package for YouTube. And the Motor 4 video, we're going to right click on and copy that and then click on YouTube, right click on YouTube and go down to paste. And we're just going to add PID onto the end of Motor 4, but I messed that up, so let me retype it. So Motor 4 PID and push enter. And then what we're going to do is go to new member training and open up my notes here for the PID controller. Drop this down to the bottom so we can do split screen like we have in previous videos, and then close the project tab over here on the left so that we can get some more screen real estate. So let me go ahead and scroll up in my notes here and scroll up to the top on our new op mode with the PID. So our configuration file and disabled teleop and the class name are all going to be taken care of for us if you made a copy from the previous video. So let me go ahead and scroll down in my notes to the variables that we have. And I did notice some problems there. These are previous videos, 1, 2, and 3, motors 1, 2, and 3. I wanted to go ahead and fix this variable right here. We didn't put motor 4 in the previous video in front of it, and that doesn't correspond to what I have in the notes here. So a good chance to make sure you know how to do refactoring. So I'm going to right click, go to refactor and rename. And then I'm going to go to the front and just add on a motor 4 and then change the C to capital so that it follows the normal naming scheme in Java for lower camel case, and push enter. And anywhere that I use that variable, it's going to now change it to the current one. I don't have to go down in the code further down in the lines and find every time that I use that and change it. By using refactor, it does it automatically for me. So I'm going to do the same thing here on this one. So right click, refactor, rename, and then call this motor 4. And then change the M and max to capital and push enter. And so that's going to refactor throughout the entire code for me. Okay, the next thing that I want to do is take a look at our run op mode. We're not going to be running our velocity test, so I'm going to control / and comment that out. And what we're going to need to do is put a new function in here to run our PID controller. So what I want to do in my notes is I'm going to scroll all the way to the bottom, and we're not going to do telemetry yet, but I've got this op mode, or this function, that I want to add to my op mode. So I'm going to do the same thing here. I'm going to scroll all the way to the bottom and find my telemetry, and then come right back up above that, put in 2 enters and paste that in. So let's talk about this motor 4 function. Okay, so it's a similar function that we've made in previous videos. It's got public void, so it's not going to give us any information back. And then our function name, followed by parentheses with something actually in it. I wanted to highlight that instead of dragging. Well, I won't highlight it, but this is called a parameter down here. When we use it, it's called an argument. But basically, it's just a local variable. So when we use this function, when we call it, it's going to feed a number into the information used inside this function between the 2 code blocks. Okay, so we're basically creating a local variable that's a double. We're calling it velocity, and when we use it, it's going to feed a number into the variable that's going to then plug in wherever we see velocity. So we're basically setting our velocity for motor 4 to whatever number we feed in. We're then going to using this variable we've already created. I can control click on that. Current velocity is way up here. It's defined in the global variables. It's set to 0. So let me scroll all the way back down and find that. So a variable has already been created called current velocity. We're going to set that every time it runs this function to whatever the get velocity function is calling for motor 4. So it's going to store it inside memory space, inside this variable. And then we're going to run a conditional statement if the current velocity is greater than the maximum velocity, which is also defined up top and is set to 0 to begin with. So if the current velocity is bigger than whatever is stored in the maximum velocity, which right now is 0, then it's going to take that maximum velocity and set that equal to the current velocity. So in other words, we're creating a method to track how big is the maximum velocity getting for this particular op mode. Something very similar to what we ran in the previous video. Matter of fact, I think it might be exactly the same. But instead of running to a power, we're running to a specific velocity on the motor. So that's really the big difference between the function here. So what we want to do now is use this function. So I'm going to Control C and go up and put this in our run op mode. So let me go all the way back to the top so that we can put this in. And that goes, instead of our max velocity test, we're going to be running this motor 4 function that we just created. So I put in my parentheses, I'm going to put in my semicolon. Now it's got a red line under it because it's asking for a number. Okay, so what number are we going to put in there? Well, we should be using a variable instead of a hard-coded number. So that number is going to be our target velocity, and that particular variable we have not created yet. Okay, so what we need to do is create some variables here, and what I'm going to do is come down here and find that. Actually, I need to go up and find those. So here's the variables that we have. We have all of these that we created in the previous one. And this one right here, I made a note, is not being used. We're not using power, we're using velocity now in this particular PID build for tuning it manually. So what we're going to do is add these variables. So I'm going to copy these and we'll discuss them real quick. So our target velocity we have set to 800. In the previous video, we did our max velocity test, and I'm just putting a number in here randomly because I don't actually have a control hub to use. My team is using all of them, so I'm just making up a fictitious number here, so 2800, and I'm putting that in as whatever result we got from our max velocity test. So note that we want to talk about here down below is our recommendation is that you don't do more than 80% of your maximum velocity. So you can plug it into a calculator, take 80%, so 0.8 times 2800 to find out the maximum number you should set your target velocity to. So let me make sure you understand those terms. This is the maximum that our motor could do. We did this we found this number in the last video. This one right here is what we're going to actually run our motor to. So when we ramp it up to a certain velocity, it's going to hold that velocity. So we're trying to use the PID controller in the background to manage the motor to run at this. Instead of saying run at 80% power, we're saying run at a specific velocity. The benefit here is that if you're running to a specific velocity, it will hold that velocity, and the PID will maintain that velocity either up or down just by a little bit. But instead using power, if we were to use power, that number might drift down over time because the battery loses its charge, right? So we're trying to use a PID controller to manage the velocity of a motor. That's the whole goal here. So our target velocity is going to be 800. And then we start to use a bunch of these math calculations. So all 5 of these terms are actually discussed in a document that we found right here. We'll put this in the description so you can click on it, but it's a Google Doc put out by First Global. And actually, let me go ahead and show you that. So I have that pulled up here. So let me scroll to the top. When you click on the link, it'll take you to this First Global PID tuning guide. This is a big key to us figuring out how to do the PID controller. So as I scroll down here, we're doing this not in blocks, but we're doing it in Java. So there's an explanation of what to do in Java. And then you see all of these variables that we have plugged in and kind of we're discussing how to use them, but it's documented here in this Google document. And then I'll show you the link in just a second. We also found and watched this video called PIDs Simplified or PID Simplified that we found very useful in understanding how to tune your PID, the proportional, integral, and derivative part of the controller. So those are two resources that you'll probably want to check out. So let me come back to actually explaining some of these settings. So F is a term, or is a variable that you'll plug in, and it's calculated using that function that you saw on the document. It's literally straight out of the document. Let me pull it up again real quick. So this formula right here. Now F, the physics person in me wants to say that that's force, but I'm not for sure. I don't see any documentation on what that actually is. If you know, throw that in the comments for us. But I am guessing it means force, but I'm not particularly for sure on that particular one. The other one we don't really understand is position. I'm trying to find that. It says to put position. Here it is. Position is 5. It doesn't really describe what those two terms are. And then the YouTube video explains PID if you don't know what those are, at least how to tune them. So we're getting all of this information from the document. So there's our F. It's the calculation that you see in the document. I, just our initial setup is 1/10 of whatever F is. And then I think I maybe said I, but P is 1/10 of whatever F is. I is 1/10 of whatever P is. And then D is 1/100th of whatever P is. So those are just to get initial numbers. That's not what we're going to end up with. Those are just initial ballpark numbers to start out the tuning process with. And again, we're using the documentation to get those formulas. And then position is a number that we'll plug into the controller. We'll pass the controller this position 5. Again, I don't know exactly what that means, but I do know that it works. So we just plug that number in. So there's the variables that we have set up. We'll come back for these comments a little bit later as we get into the tuning, but right now we're just setting it up. Again, this documentation will be down in the description of the video so that you can find that. So let me continue on then. So motor 4, init motor 4, we already have set up. That would be the next piece inside this, inside my notes here. Now you do notice that it's different, but again, we haven't made any changes to this init for motor 4, so we can't pass the arguments to it that you see in there. So we'll come back to this after we set up motor 4. So we have to make some changes here to get this to work. So let me drop down and do those next. These are variables, or again, parameters that we're going to now put inside our parentheses. So when we use this function now, we've got to pass it 5 different numbers. Well, those numbers are the variables that we just created. So we created a KP, KI, KD, F, and position using the document that we described. And then a lot of the setup is the same. So we're going to have to add a couple lines, but let's double check, make sure we got everything right. We've got a DC motor extended. So that is already done for us because of the previous video. We're going in the forward direction. We're setting it to 0 power when we init it. And we're setting it to float, so in other words, it'll just coast to a stop instead of using the motor to stop it. The next thing is that we're going to start to use these variables that we created. So we need to add these 2 lines. So they're setting the velocity. I'm going to copy those 2. After float, I'm going to drop those in. And when we set the coefficients for the PID, we need to pass it these 4 arguments. And then this one is a different one. Oh, here it is, position. So set position. We're going to use the position variable that's basically substituting in the number 5. Okay, and then stop and reset encoder and run using encoder now. We were running without encoder because we didn't want the built-in PID managing it. So we want to change it to run using the encoder now. So let's change that. And so now this is set up, but when we call this function up top, now we've got a red mark because we're not passing it the numbers that we need. So now we want to pass it these 5 variables. Again, where am I getting that from? So down here, we created these parameters as the technical name for it. So we created those parameters, and now we're going to pass it arguments for those parameters. So now KP, KI, KD, F, and position that are used up here. Where's that at? Right here. Are now calling, it's calling these variables into that particular place. Okay, so that's the init setup. Now, the next thing that we need to do is come back down here. I noticed and got a little bit distracted. I saw this error. So when we ran the function, we didn't have the variable set up. We said we'd have to come back to that. So what we need to do is pass it now the target velocity. We didn't have that variable created. I'm going to plug that in right here. And so now that argument is then entered to satisfy the parameter that was required. So I'm going to hover over the method call and click on it. So control click it, and it'll take me back down here. So now we have a parameter, and we've passed it the argument up top. So now all the errors are gone over here on the right hand side, and it's perfectly happy with this particular method. Let me double check, make sure so far I haven't caused any errors or missed anything. I know I haven't done the telemetry, and then we need to get into the actual tuning. But as far as the setup, I think we are done. We just need to add our telemetry into our motor telemetry function. So I'm going to copy this, scroll all the way to the bottom, and I'm going to comment out these. So control /, and I'm going to push enter and paste these in case you were wondering if this is the first video you stumbled on. Our previous videos, motor 1, 2, and 3, and 4 actually, we use these telemetry pieces, and we're just layering things into this particular op mode. So we're just commenting those out so we can use them later if we need. But for this tuning process, we want all of these pieces of telemetry. So what is the power being sent to the motor? What percentage is that power? Our target velocity we're setting, but just to print it out so we know, so the user knows what's our target velocity. Our current velocity, so it's getting that off of the encoder data and printing that to the screen. The maximum velocity, and we'll explain why we need that here in a minute, but the maximum velocity that this particular motor has achieved during the op mode. And then what are our calculated, because remember these are being calculated for us, what are these values being calculated to actually in decimal form? Okay, so we have all of this telemetry being output to the driver hub so that we can see what it is. So now if I scroll back up, I'm going to take a look at those variables. It's way up here it looks like. There we go. Okay, so now we need to start discussing what each one of these does. So when you run this op mode, you've got your maximum velocity, you've got a target velocity set, and all of these things are being ran by a math calculation in the background. Well, eventually we're going to move away from these math calculations and use a manually inputted number. So the first one we're going to manually tune is P. F is calculated for us, and we're not ever going to change that. We're just going to leave this one alone, but we're going to manually tune P. So it's being calculated for us automatically by this equation, but what we're going to do is remove that and put in a number, say 0.4. I don't know what that number will be. I'm just making up a number, but we're going to manually tune P, and then we're going to manually tune D, and then we're going to manually tune I is the process that we'll go through that. Again, this is explained a little bit in that video. The video is about, the YouTube video that I referenced is about quadcopters, but it's still manually tuning a PID controller. So the order that we'll go through again is P, and then the D, and then the I. So let me push Control Z so we can get back to the math calculation here. Okay, so what we want to do on P is bring up the velocity as quickly as we can to the target velocity. So the motor is going to start at 0. We want to bring it up to 800 as fast as possible without much of an overshoot. So if we go up to 820, 840, by the way, the increments for the velocity is in 20s. So 820, 840, 860, 880, then 900. So if it goes way past, if we run this op mode and it goes way past 800, our P is too high. It's overshooting. And that will cause a lot of oscillation. So discuss P term oscillation. I have a note here to discuss that. We want it to come up to the target velocity as fast as possible without doing a lot of overshoot. Now, say 840, 860 would maybe be okay, but if we're going way past that and our maximum velocity output onto the screen is getting way above 800, then we need to lower our P. Remember, this math calculation is just a ballpark. So if you come down here on if you look at your driver hub, we're outputting the P number. You're going to get that number, that calculation on your screen. If we are overshooting a lot, then we want to lower this number. If we're undershooting it, we never reach the target velocity, then we want to obviously raise KP. Okay, so you're going to adjust K first, and then we'll move on to the D function, or the D term. So say we have P down to, we read it on the driver hub, and it was, I don't know, 0.8, and it's overshooting. So we drop it to 0.75. So I'm just randomly picking a number. So 0.75 is what we end up on KP. Okay, we would upload it and run this function again. And then what we're looking for in the D term applies a braking force to the control, to control overshoot. So if we're blowing past it, what it basically does is add a force in the opposite direction to get it to slow down and hit its target. So we want this to be as small as possible because it causes what's called D-term noise. So basically a little blip, a little bit off early in the process of running and tuning this will cause an error, and the errors have a little bit of a delay before they show up actually in the calculation when it's running this in the background. So it can cause an even bigger blip further down the line, and it starts to just turn into a mess. Basically, we call that noise. Again, watch the referenced video and it will explain that. So we want this to be as low as possible with while still achieving our target. So the next thing that we're going to achieve after tuning the P is tuning the D. So again, you're going to upload P, run it, find out what your D value is now. And then what we want to do is how quickly does that come back and center on 800? Are we still, our KP value should still be taking us up to 820, 840, something like that. But then the current velocity should quickly bring us back down to the target value of 800. Okay, so that's what you're tuning the KD to do. So you're going to change this number. You're going to read it on the driver hub, find out what that number is, change that number in here, and then manually tune this number until you get it to be right at 800 as fast as possible. So KP will take it up to it. KD will add that braking force in the opposite direction. But again, you want to keep this number as small as possible so it doesn't cause noise. The last thing that we want to do once we add these two numbers and upload the code then to the driver hub is we want to tune the KI. The KI is going to give it a little nudge in the positive direction to get it up to our target velocity. So a little bit better way of understanding that, I guess. Say for you run your op mode and it runs up to 780 and it takes a couple seconds for it to get all the way up to 800. What you can do is increase the KI to get it to give it a little bit of a nudge to add a little bit to P when it's off, is the best way to explain that. So it gives it a nudge towards your target in case that it's not getting there over an extended period of time. If it takes it too much time to get there, then you're going to want to raise your KP or KI value, KI value. So again, you get these off of the driver hub. find out what the number is, and then you can plug those numbers in here and manually tune them to get your PID manually tuned in for that particular motor and the target velocity that you're wanting to run it. Okay, so hopefully that makes sense. The setup process is actually the easy part. The manually tuning part takes a little while because you are changing a number, just like I did here, from the calculated values, and then messing with that number until you get it exactly on. These calculations will get you in the ballpark, and then you're manually tuning the numbers to get it right on in the sweet spot that you want it for your PID controller, using that specific motor and the specific target velocity that you're trying to achieve. Okay, so hopefully that's clear. If not, go back and rewatch the video. It did take us a little bit of a process to learn how to do this, but hopefully that's all helpful for you. In the very next video, it looks like we're going to be talking about the blinking controller and adding LED lights to your robot. So if you're interested in that, tune back in for that video. Otherwise, have a great day and hope to catch you in the next video. Bye-bye.